Alright, in this video we're going to take a look at section 9.1 where we're studying the ellipse. But first let's review the circle a little bit here. Remember an equation of our circle? X squared plus y squared is equal to 1. Certain things that we're concerned with in the circle is the center of the circle, the radius of the circle, the circumference, and the area. Those are kind of the things we take a look at. Now on an ellipse, notice all we're going to do is to make an ellipse, we're going to take our circle and distort it a little bit. And so if you look at our equation down here, here's how we distort it a little bit. Notice kind of the root of this equation is based on the circle. So if we take a look here, you notice we got x squared plus y squared is equal to 1, but this a and this b kind of stretch or shrink the edges of the circle to form the ellipse here. Alright, and here are the things that we're concerned about, or some of the things we're concerned about when we're taking a look at the ellipse. So we got the center of our ellipse, and then we've got two axes here. We've got a major axis, which is our longer one, and a minor axis, which is our smaller one. The vertex are the endpoints of our major axis, and the only thing that makes it a major axis is just a longer one. And then we've got two other things here, the foci, and the foci I'm just kind of going to estimate it here. Let's say right about there and right about there. Foci always lie on the major axis, and they're always equidistant from the center of our circle. All right, I'm going to show you a way in this video how to find the actual locations of these foci. So those are kind of the parts of the ellipse. Major, minor axis. Notice this can be shifted. You know, right now I have a minor axis going on the y-axis and a major axis going kind of with an x-axis here. This can be shifted or stretched the other way. And the way this gets shifted or stretched basically is this, is if A is larger than B, then this stretch going on in the x direction will be greater, creating this to be a major axis and this to be a minor axis. If we take B and make that larger, then what happens is it stretches the ellipse vertically here and changes our major axis to a y. Alright, let's take a look at a definition. An ellipse is the set of all points in a plane where the sum of the distances between two fixed points, and those fixed points are the foci, is constant. Alright, let's kind of dig down deeper and see what this actually means now. So the set of all points in a plane, it has to be in a plane because we want to be two-dimensional here in our ellipse. That's why we have to be in a plane. The sum of the distances, so basically let's see what that looks like. Let's get a different color pen here. So if we take, and I take a point on the edge of the ellipse, then the distance from here to here, let's call that d sub 1. And then the distance from here to here, we'll call that d sub 2. So basically, if I take d sub 1 plus d sub 2, it's always equal to some constant value, no matter where I am on the ellipse. Notice, if I shift my point over to here, notice d sub 1 is getting longer, but d sub 2 is getting shorter. The sum of those two distances will always stay the same, no matter where I go on the ellipse. And that's kind of what it is. So it's the set of all of these points around here on the ellipse, or all of those locations where the sum of these two distances is the same. So now that we got a general idea of kind of what an ellipse is, let's take a look at some of the math surrounding it. So the standard form an ellipse equation, where the center is at the origin, and A is greater than B, we have two things. We have a major axis that's horizontal. So our major axis is horizontal. Our equation is going to look like this. And notice A is greater than B. The reason we have that is because we're going to try to define which of these two values is larger. So notice if A is greater, then what's going to happen is we are going to stretch our equation horizontally. Or sorry, we're going to stretch our ellipse horizontally and create a major axis here going in the parallel to the x-axis, or in this case, if it's centered the origin, it will be right on the x-axis. So if A is larger here under our x, we know we're stretching the ellipse this way. Here are the coordinates of our vertex. A positive a0 and negative a0. And then here are the endpoints of our minor axis. Notice when we say the endpoints of our major axis, we call those the vertex or vertices. The endpoints of our minor axis are just called the endpoints of the minor axis. All right, notice this distance, if we were to graph this thing, notice in our equation this is a squared. This distance that we're traveling here is just a, though. So whatever this number is, we take the square root of it then to figure out how much the ellipse gets stretched in this direction from the origin. Same with b. b squared here, but then we're just traveling a distance from the center of our ellipse up b and then down b. Here are our two foci in this particular case, and the way we find the foci is this right here. This comes from the Pythagorean theorem. And so to figure out this distance of c, notice we're traveling out from the center of our ellipse a distance of c. All we do is use this little equation, c squared equals a squared minus b squared. Now, if our major axis is vertical, that means this value is larger than this one. So it's getting stretched more in this direction. So it's getting stretched more here. So our vertices would be at the endpoints of our major axis. These would be our minor axis endpoints. Everything else is kind of the same. You know, we would still find c, the distance from our center, up c units to find the foci using this equation. So really, whether it's getting stretched more horizontally or vertically just depends on whether a or the denominator of our y value is larger. Okay, and like all of our other equations in this class, we've been translating these things around, and so our ellipse is also going to get translated around. And so you'll notice if we're going to have a translation here, we would have, instead of just x in the numerator, I'd have x plus or minus some value, and then y plus or minus some value. And notice, just like before, it's always kind of set up the opposite of what you see or think. So if it's x minus h, notice that's shifting the center of our ellipse h units to the right. And if it's y minus k, it's shifting it k units up. If there are addition signs in here, that means they're actually shifting them in a negative direction. All right, let's take a look now at graphing an ellipse. So I've given you an equation for an ellipse here. I kind of didn't organize it perfectly, so we're going to have to do a little bit of work to organize this before we can graph it. Notice one thing about all of our equations for an ellipse or a circle is we need to have a value of 1 on the right side. And notice I have a value of 144 here. So what we're going to want to do is do some division, get this thing in the right form, and then go ahead and graph that. So go ahead and pause your video player now and see if you can graph that ellipse. When you get done, hit play to see how you did. All right, so what I'm going to do is I'm going to divide everything by 144 so that I can have this value of 1 on that side. That's important. We can't graph any ellipses without a value of 1 on the right side. Now let's look to simplify each of these fractions. Looks like a common factor of 16 could be divided out of those. Hopefully you found that, which would leave us with this, x squared over 9. And this next one, a common factor of 9 could be divided out of those fractions, which would leave us with y squared over 16. Okay, notice since this is just x all by itself and y all by itself, there are no shifts, so the center of our ellipse is right at the origin. Now notice my a here, we would consider this a since y has got a larger value under it. This is going to be our major axis and more of a stretch here. So this value 16, the square root of that is going to be how far it stretches in each of these directions. So the square root of 16 is a stretch of 4 in each direction. So I'd come over here with my y values, and this is going to get stretched 4 units up and 4 units down. So 1, 2, 3, 4. 4 up and 4 down. 1, 2, 3, 4. Okay, let's look at the stretch in the x direction. If this value is 9, the square root of that would be 3. So that's the stretch that's going to happen there. So 1, 2, 3. And then 3. So I'll go ahead and try to sketch this out. We don't have to be perfect at our ellipse drawing in here. Okay. Now the only other thing I need to do is I need to now, on my graph, I also need to identify the foci. So let's use this equation for the foci. C squared is equal to a squared minus b squared. So c squared. Notice these values up here are actually already a squared and b squared. So a squared in this case will be the larger value, the one under y. So that would be 16 minus 9. And so we get c squared is equal to, looks like 7. And so then c would be equal to the square root of 7. Now if I'm going to graph this, I need to get an approximation for that value. So let's see, 7, take the square root of that, 2.65 about. And since our graph is not going to be perfectly accurate, we don't really need to be that precise here. But so we're going to go up now. My foci are going to be on the major axis, up 2.65, so right about there, and then down 2.65, so right about there. So those are the locations of my foci. All right, now let's try to graph an ellipse that has been shifted. So again, we're going to graph the ellipse and find the foci. So go ahead and pause your video player now and graph this ellipse, and when you get done, hit play to see how you did. All right, let's take a look. So first thing we need to do is identify the center. Looks like a -1 here, so that means it's going to actually shift the opposite way, +1 in the x direction. We've got a +2 here, that means it's actually going to shift the opposite, -2 in the y direction. So our center is over 1 down 2. There's our center. Now let's take a look at our stretches. This is a squared here, b squared there. It's a squared here because the 9 is greater, that's all. So let's take a look at our greater one first. That will be our major axis. If this is 9, that means the stretch is going to be the square root of that, which is 3. So in the y direction, we're going to stretch this ellipse 3 units each way. So I'd come to my center and go up 1, 2, 3, and then come down 1, 2, 3. All right. Stretch in the x direction. Since this value is 4, my stretch is going to be the square root of that, which is 2. So come back to my center, 1, 2, and then 1, 2. All right, let's go ahead and try our best at sketching this ellipse out. All right, now let's go ahead and identify the foci. And that's just the plural of focus, foci. All right, and again, we're using that same c squared equals a squared minus b squared. A is always my larger value, so let's see, c squared. This is actually a squared there, so it's 9. B squared is 4. So c squared is going to be 5. So c is going to be the square root of 5. Get our calculator out to get an approximation of that. 2.23. So we are stretching now on our major axis, which is our y. We know that because that's the one that's been stretched the most. And I'm going to go up 2 and 2.3. So let's see. 1, 2, and 2.23. So right about in there, maybe somewhere. Then down 2. 1, 2, 2.3. So right about there. All right. Now we're going to look at a question here. We're going to need to complete the square to get this thing organized so that we can graph this ellipse. So what we're kind of shooting for here, notice I have everything kind of unorganized. This doesn't look anything like our ellipse equation from before. This is going to be a shifted graph. Let's kind of scroll back up here and look at our last one. So when we get done with this, it's going to look like this. So let's note a couple things about this, the way we want to organize it. Notice we need a 1 right there. We've already talked about that a couple times. We also need these numerators to be perfect squares. Notice this one is y plus 2 squared. This one is x minus 1 squared. So those are perfect squares, and so we're going to need those in the numerator. Let's scroll back down to our problem at hand here. So the first thing we're going to want to do is get our x terms together, get our y terms together, and think about completing the square here. So I'm going to kind of get us started on this, and then we'll have you guys kind of finish it up. So let's see. So the first thing I would want to do is collect my x terms together. And since I want this to be a perfect square, I'm going to leave a little box right there of the value that I'll need to add to make it a perfect square. I'll do the same thing for my y's here. Now this 11, that's kind of going to get in the way. So I'm just going to take that 11 and get it over on the right side. So I'll add 11 to each side. Get it like that. I'm almost ready to start looking at completing the squares, but before I do that, I want to see if I could factor anything out of these two terms, and again factor anything out of those terms, and I can. This first one I could factor a 9 out. So x squared minus 2x plus some mystery value. And here I could factor a 4 out. Alright, now we're kind of in a good spot here. Go ahead and pause your video player, complete these squares, and then organize this so it looks like an ellipse. Once you get it organized, then you could go ahead and graph it. So go ahead and pause your video player and give this a shot, and when you get done, hit play to see how you did. Alright, so let's see. Let's look first start at completing these squares. So if we have a leading coefficient of 1 here, it's really easy to complete the square. The value I need at the end here is just 1/2 of my middle term squared. So 1/2 of 2 is 1. Square 1, that's going to be 1. So it would look like this. X squared minus 2x plus 1. Same thing here, leading coefficient of 1. So I'm taking 1/2 of the middle term and squaring it. Well, 1/2 of 4 is 2. 2 squared is 4. So plus 4 there equals 11. Now, notice when I put this value in here, this 1 value in there, and this 4 value in there, I've increased the left side. I need to balance the equation and add those same amounts to the right side. Well, let's take a look here. When I added a 1 there, I'm actually increasing that value by 9, because notice this 9 would get distributed and multiply times that 1. So that increased by 9 when I put that 1 there. So I'm going to add 9 to this side. Here, when I put the 4 there, it actually increased the left side by 16, because 4 times 4 would give me 16. So plus 16 there. Alright, let's add these values up. 11 and 9 is 20, plus 16 is 36. Now let's write these out as perfect squares, because that's what they are now. So this will be 9 times x minus 1 squared, and this will be 4 times y plus 2 squared. I need a 1 here, so my next step would be divide everything by 36. Let's see, so I have a 1 there. Here I could divide out a common factor of 4. So that would be y plus 2 squared. When I divide that common factor of 4 out, it would leave a 9 in the denominator. Here I can divide a common factor of 9 out. So it would be x minus 1 squared over 4. Now I have got my equation all set up in the form of an ellipse, and I'm ready to graph it. So let's scroll down here and graph this guy. Alright, so first let's find the center. And the center, notice if it's x minus 1, that means it's shifting to the right 1. So my x coordinate is shifted to the right 1. Y plus 2, that means it's actually shifted down 2. So I'm going to have the center will be at 1, negative 2. So come over to my graph, 1, negative 2. Got my center. Now let's find my stretches. It looks like my y value is going to be my major axis here since it's larger. So if this is 9, that means the stretch is 3. So I go up and down from this point 3. So 1, 2, 3. There's a vertex. 1, 2, 3. There's another vertex. Let's see, my x is, since this is 4, is going to get shifted 2 in both directions for the x. So come back to my center, 1, 2. Minor axis endpoint, 1, 2. Okay. Go ahead and sketch my ellipse out there. I didn't ask you to find the foci, but if we needed to find the foci, all we would need to do is use that equation to find C, and then since my major axis is a y here, I would go up C and down C to identify where the foci are. Alright, that's the end of the video, so hopefully you've got a good handle on this now. You're ready to go off and work on your My Math Lab assignment.